Okay. All right. Hi guys. So this video is going to be on the notes from section 7.1 as well as the homework examples from section 7.1. So I'm going to follow the notes first. So this is chapter 7 and section 1. So 7.1. All right, and this is really on proving trig identities. The first set of identities would be called the Pythagorean identity. And so the first one is going to be sine square theta plus cosine square theta is going to be equal to 1. And you can prove this really from the unit circle. So if you recall from the unit circle, I have my angle theta. And for each angle theta, I have a unique point on the unit circle, and I'll call this point xy. And because this is a unit circle, this is of length 1. And if I draw my x and y, here's my x, here is my y, we form a right triangle. And so the relationship between x, y, and 1 is that if I take x squared plus y squared, I'll get the hypotenuse squared. So that's a 1 square. But then 1 squared is just 1. So x squared plus y squared is 1. But how trig is defined is that if I take cosine of theta, by definition, that's going to give me x. If I take sine of theta, that's going to give me y. So in place of cosine here, I can just simply write, in place of x, I can simply write just cosine of theta squared. In place of y, I can write sine theta squared. And that is a little bit awkward because here I am putting a bracket around the whole cosine theta, and then that whole thing is square. A better notation would be to place that square right next to that cosine. So it means exactly the same thing, except now you don't have to write that bracket. Okay? So this identity comes from the Pythagorean theorem, so that's why it's called a Pythagorean identity. All right, there's two more. Once you get this identity, all you have to do is take this equation and start playing around with it. So one way is by taking this equation. So if I take sine square theta plus cosine square theta is equal to 1, I can do anything to one side as long as I do the same thing to the other side. So in this case, first thing I'm going to do is just really divide everything on the left by cosine square. And that means I have to divide everything on the right side of this equation by cosine square as well. So everything on the left side of this equation divide by cosine square. Cosine square theta. Cosine square theta. Cosine square theta. So what is that going to give me? Well, sine square over cosine square, you can rewrite that as really a tangent, right? Because sine over cosine is tangent. So let me just write that as tangent square theta. How about cosine square over cosine square? Well, that's a 1. And here, 1 over cosine, that's by definition secant. But it's cosine square, so this is going to be secant square. and that's going to be the second identity. This is the first. Okay. How do I get the third? Well, you start with the first identity, and that's a sine square theta plus cosine square theta is equal to 1. And now instead of dividing everything by cosine square, I'm going to divide everything by sine square. So this guy is going to be divided by sine square as well. On the right side, divide 1 by sine square. And then we'll simplify. And this will give us the third identity. Why can I do this? Because here you have an equation. I can do anything to one side as long as I do the same thing to the other side, right? This is algebra. It's called balancing out the equation. So sine square divided by sine square is a 1. Cosine square divided by sine square, well, that's not tangent. Tangent is sine on top, cosine on the bottom. This is cosine on top, sine on the bottom. So this is going to be cotangent square. And 1 over sine, well, that's cosecant, but I have sine square, so this is going to be cosecant square. And that's my third identity. Any questions on this? Let me know. I'll be in the chat room from 10:45 a.m. to 12:05 a.m. every Tuesday and Thursday. Okay, so I did a few examples to show you guys how you would apply these identity. So for the first example, for any theta, this equation is true, so I decided to use theta being 30. Nothing special about 30. Why did I decide on 30? Well, it's a nice angle, and it's one of those angles where I don't have to use a calculator to evaluate sine or cosine. I'll show you that the left side is indeed equal to 1, and that would prove that this identity does work. Okay, so what is sine 30? Well, sine 30, that's opposite of 30 degree on a 30, 60, 90 degree right triangle. So opposite of 30 is going to be 1/2. And I'm squaring that. Cosine of 30 would be adjacent to 30. And that's going to be the root 3 over 2. I'm going to square that. And we'll see that this is equal to 1. So 1 squares of 1, 2 squares of 4. If I square the square root of 3, I get a 3. And down here is a 4, because that's a 2 square. And that is going to be 1. 1/4 plus 3/4 is 1. Check. Okay. There is also example 2, where I apply the second identity. And this is true for any theta. So I decided to use 45. Just something to plug in. Nothing special about 45 other than the fact that I actually do know what tangent of 45 is without having to use a calculator. So, well, tangent 45, that's sine of 45 over cosine of 45. Sine and cosine of 45, they're both the same, so this is actually going to give me a 1. Okay, and it's a 1 square because it's tangent square. Here's a 1. Secant of 45, how do I evaluate secant of 45? Well, it's the reciprocal of cosine of 45, right? Secant is 1 over cosine. So if I know that cosine of 45 degree is root 2 over 2, and I know that secant of 45 degree is 1 over cosine of 45, it just means that I'm going to take the reciprocal of this guy. So if cosine is root 2 over 2, secant of 45 is going to be 2 over root 2. Okay. So 1 squared is a 1. What is 1 plus 1? That's a 2. If I take 2 squared, that's a 4. If I take root 2 squared, that's a 2. And is 2 equal to 4 divided by 2? Yes. Okay. And then for the third example, you can follow my notes to see step by step, but I think you guys do get the point now. For that third identity, I decided to use theta being 60 degree. So it's cotangent of 60 is equal to cosecant square of 60. And you can follow my notes to see that indeed the left side is equal to the right side, okay? All right, so that's the first set of identities. We have the second set, and that will be the reciprocal identities. And there's really nothing much to prove. It really comes from, you can say it's from the definition. So we define secant theta to be 1 over cosine theta. And just from algebra, if you have a fraction, a over b is equal to c over d, you can do something called cross multiplication. So if a over b is equal to c over d, then I can take a times d, and that's equal to b times c. Okay? On the right side, we have a fraction. On the left side, we do not have a fraction, but that's really over 1.